All right, JeWeL bowling fans, Josh with another Tips and Trick Thursday. This week we're going to be focusing on finding your positive access point, and then we're going to be looking at layouts, understanding what the different layouts are for a bowling ball so that you can better understand what you can anticipate from each of your bowling balls to do on the lanes. How you build that arsenal is not just about cover, stock, and core, but also about what are the layouts on your bowling balls as well. So we're going to dive into it. So when we talk about positive access point, this is critical because this is unique to each individual bowler. Knowing what your positive access point is going to help your pro shop operator determine how to lay out the bowling ball to do exactly what you want it to do. We can take that positive access point and put a variety of different layouts on a bowling ball to do different things. How you release the bowling ball is going to dictate what your positive access point is. So if you release the ball different every time, that positive access point will shift around. So we can use that to our benefit, but it can also be a detriment if you are trying to do a similar release every time or get the similar ball motion. So we're going to look at today about how to find the positive access point, and then obviously what it means and how we use that positive access point to understand how to drill different layouts on the bowling ball.
There are a couple of different ways to find your positive access point. One, if you have a pro shop operator with you, you can use an armadillo like we're going to use in this video. But either way, we're going to start by throwing a few shots down the lane to get some oil track lines on the bowling ball. Once the bowling ball comes back, we're going to locate that first track line and that first instance of the oil line on the ball. And what we're going to do is we're going to trace that oil line for a large portion around around the bowling ball. We're going to use that oil line mark to determine the positive access point. If you don't have this tool that we're going to use called an armadillo in a second, what you can do after drawing the first oil mark on the bowling ball is take that ball and put it on a ball spinner, keeping that line horizontal to the ball cup. The top of the bowling ball at that point would then indicate your positive access point. Using the armadillo, though, it is a tool that has many different lines on it. What we do is we find the line on the armadillo that matches as closely to the arc drawn on that first oil track line. Once we find it, we then take the pencil and make a mark at the end of the tool. That is the positive access point mark. So if you don't have a really sharp pencil, make a larger mark. What we're going to do here is we're going to make a big circle where that positive access point is so that when Jeff throws another shot, we can try and watch it going down the lane. As Jeff throws another shot, we're going to watch that yellow dot and see if it's moving while the ball is going down the lane. In this case, it's not, so that indicates we found the positive access point properly. You can use this same process while practicing, taking a piece of tape and putting it on your suspected positive access point. You can watch the ball travel down the lane, watch that tape as you throw shots to see if that tape is moving. Not only will it help you find your positive access point, it can also tell you if you're releasing the ball consistently every time by watching the rotation or movement of that tape throughout your shots. Once we have the positive access point mark, we need to find what the distances are from the center of grip to that positive access point. We first draw a line for the midline between your fingers and your thumb, or in this case, just fingers, and then we draw a center of grip line. For a no thumb bowler, that's between the two fingers. If you have your thumb, measure the distance between your top of your fingers and your thumb, divide it in two, and draw your center of grip. We're then going to draw a horizontal line from that center of grip directly over. So you can see here I've got the mark for the prosect along that line. And then we also draw a vertical line from that horizontal through the positive access point. We then measure over to that vertical line and measure down or up to the positive access point. That is going to give us the two dimensions, horizontally and vertical, of the positive access point. In Jeff's case, 5.5 by 3 3/4.
So we're going to start by talking about dual angle layouts. We'll also talk about the vector layout system by Storm. But what we're going to do is talk about what all the numbers mean relative to the positive axis point. Okay, so here we have my reality laid out. And the first thing that I'm going to do when I go to drill this bowling ball, imagine no holes are in it, is I'm going to draw a line from the pin to the mass bias, or the positive spin axis, okay, on an asymmetrical bowling ball. On a symmetrical bowling ball, you would draw a line from the pin through the CG, okay? The next step is I'm going to figure out what I want my first angle in the dual angle layout system to be. So I have my prosect here, and you'll see I lined it up on that line, and this angle is a 40-degree angle. That's what the first number means, is this angle between the pin to positive spin axis and pin to PAP, okay? The next thing we're going to do is figure out a pin to positive axis point distance. So in this case, we're right about 4.5, give or take. 4.5. So that's what the distance from here to here is. And finally, the last angle is between the pin to positive axis point line and the valve. And in this case, do the same type of thing, and you'll notice I've got this right about 40 degrees. Okay? So those are the three numbers. Angle 1, pin to PAP distance, angle 2. From here, all we're going to do is, this is my positive axis point mark, and all I'm going to do is go up or down based on my positive axis point numbers, and then over to draw my midline and drill my holes. We'll actually go into drilling in a different video. But what do these numbers mean? So when we talk about dual angle, the first angle, so pin to PSA and pin to PAP, that first angle is going to dictate how quickly the ball transitions from skidding down the lane to hooking. So skid to hook transition. The smaller the angle, the faster that transition. So the earlier the ball is going to transition into hook. Likely want to be used on longer oil patterns, trying to get that ball to read the lane sooner. It could also be used for short oil patterns where you want the ball to transition very quickly and die out, depending on the ball surface. So again, first angle, skid to hook transition timing. Smaller angle, faster transition. Larger angle, so above 45, longer down the lane the ball is going to get to. So if you want a ball with a lot of length before it makes its move, larger first angle. All right, next thing we have is pin to PAP distance. This distance talks about the relative flare potential in the bowling ball. So once it makes its move, how hard and how hard is it going to move off that spot, right? How much is it going to grab the lane and move right to left or left to right? That's what the pin to PAP distance indicates. On a symmetrical bowling ball, about 3 3/8, 3 5/8, right in there, that's your max flare potential. Shorter pin to PAP distance, so kind of less than 2 inches, that's going to give you a very low flare potential. Very good for short patterns. If you don't want to throw urethane equipment, short pin to PAP distances are a good alternative, because that will give you a ball that is going to move and then stop and and not overreact. As you get longer and longer pin to PAP distance, you basically offset the core as it's going down the lane. You will see a more violent flip in the back end. And then depending on that second angle we're going to talk about in a minute, will dictate just exactly how continuous that motion is going to be. So that's pin to PAP distance. When you hear someone talk about short pin equipment, we're typically not referring to out of the box the pin to CG distance. We're rather talking about pin to positive axis point distance, because this is what's critical when it comes to flare potential. The last thing to look at is that second angle. So the angle between your pin to PAP and the valve, okay? This angle is going to dictate how continuous the motion is in the back end. So much like the first angle where it was how quickly the ball was going to transition from skid to hook, the second angle dictates how quickly the transition is going to be from hook to rolling forward or rolling out. The smaller the angle, the quicker that transition is from hook to roll out. So very good for short patterns to have small angles because the ball's not going to overreact. It's going to make its move and roll forward. Longer oil patterns where you want continuous motion, you want that ball to continue going, hooking, moving right to left, very minimal rollout, larger second angle. So again, smaller angle, faster transition from hook to roll, larger angle, slower transition or longer delayed transition from hook to roll. And that kind of dictates the layout of a bowling ball using dual angle. So now we're going to look at the storm vector layout system. Instead of having 2 angles and a pin to PAP distance, we're going to have 3 distance measurements. The first distance is one that you're already familiar with, pin to positive axis point. So in this case, our layout, it's 4.5 inches. The next distance is mass bias or positive spin axis to pin to PAP distance. In this case, it's 3.25. And the last distance measurement is the pin buffer. So imagine an arc from the pin with the valve being tangent to that arc through the positive axis point. That's the third number. And in this case, I have a 2 3/8 pin buffer. So those are our 3 dimensions, okay? 4.5 by 3.25 by 2 3/8. So what do those numbers mean? Well, if we think about it just like we did before with dual angle, as we decrease the second number, that angle that we did before in dual angle is getting smaller and smaller. So again, smaller mass bias or positive spin axis to positive axis point distance, smaller this distance, faster the transition from skid to hook phase. Pin to PAP distance is still flare potential. The back end rotation and transition is dictated by the pin buffer distance. In this case, again, the shorter the pin buffer, so as this number decreases, this angle is going to decrease in our dual angle system. So just like in dual angle, smaller the pin buffer distance, smaller the angle, and therefore faster the transition from hook to roll phase. Larger the pin buffer, wider the angle, and therefore delayed transition from hook to roll phase. 2 different ways to lay out a bowling ball depending on your preference, but ultimately what the dimensions do is going to be the same. All right, that's going to do it for this week's Tips and Trick Thursday. We talked about positive axis point, how to find it, what its purpose is, and then how to understand layouts. So next time you're looking for that new bowling ball and you can go to your pro shop operator and tell them what you want, you can double check that they're drilling it kind of around what you expect. So understanding your layouts is going to be able to enable you to find your equipment and choose the right bowling ball for the right condition much faster. So remember to like and subscribe to JeWeL Bowling channel on YouTube, and we'll see you again next week. Thank you.